Hello, SREcon. Welcome to the end of the first day. I'm really happy to be here. I actually really especially like being the last speaker of the day. Basically, it's me standing between you and cocktails. It's kind of like a power trip, especially since anyway. I'm going to talk to you about one of my very favorite subjects, which is about the basically impossible task of trying to make good decisions about software. This has been on my mind a lot lately. I have a lot to say, but first, I would just like to look around this room and think about all the stuff that you heard today and how amazing it is. It's like Rachel's keynote this morning. How fucking awesome is she? Reliability and debugging. Rachel, if I was on a mission coming back from Mars and we were in trouble and I had to pick one site reliability engineer to find and fix some obscure bug in the Linux networking stack, pretty sure I'd pick Rachel. So hearing somebody like Rachel talk about the fundamentals of reliability is really awesome and exciting. But the thing that's actually more impressive and more overwhelmingly awesome to me is just look at the schedule and the variety and the diversity and the depth and breadth, all of the different contexts that you guys are coming from to think about complex systems problems. Microsoft basically redesigning how they do technology from scratch. Brownfield development, I think they're calling it. That's amazing. Hearing from new grads who are entering the industry and what they're thinking about, their challenges. There's on-call culture and management culture and the people like Leslie who are bringing SRE stuff to networking. And I think that the sheer scope and variety and diversity of these topics would come as a big surprise to a lot of the people who aren't here in this room. Because, let's be honest, we have a reputation for being total assholes. I mean, we have a reputation for being the people who push back against change, who rate limit the change. People are not used to thinking about systems engineers as people who are driving the change and really pushing the industry forward. And everything that you hear here today and tomorrow is radically disproving that. Reliability sounds like a narrow term, but it is not a narrow topic. We're collectively learning that every technology problem is increasingly and always has been a human problem. We just didn't figure it out for a really long time. Anyway, our field is changing really fast. It's getting awesomer every year. It's getting way more fun. But we're not actually doing it because it's fun. We're doing it because we have to. Because otherwise, Moore's Law and Metcalfe's Law and Edson's Law, Edholm's Law, and population growth and global connectivity growth, all of these accelerating forces and converging feedback loops are just going to totally kick our ass. So, welcome to SREcon. Let's get back to the thing that I'm actually here to talk about, which is the art and science of making good technical decisions. And this is a skill that a lot of senior engineers have developed intuitively through making lots of mistakes. But it's a skill that's becoming much harder and more necessary, every single day. So very quickly, due credit for the theme and title of my talk, which is borrowed from Neil Stephenson's book, The Diamond Age. Who here has read The Diamond Age? So the thing that the reason I chose this theme is because it's this futuristic cyberpunk story about the future when it's full of nanites and software literally has eaten the world and probably our brains. I want to talk about the incredibly horrifying explosion in complexity of software and infrastructure and storage choices over the past few years, and what this means for you and me, who are just simple engineers trying to get through the day and make reasonably good decisions that are not going to completely fuck us over. So the outline here is basically, I'll talk about the changing landscape of technology, blah, 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 and then go deeper into some principles for things like evaluating your own specific organizational risk and appetite for risk, and making decisions, like principles for making decisions that are quote unquote good, which is a meaningless term because decisions are never good or bad, they are only contextually appropriate or not. And by the end of the talk, we're going to have a manifesto. Like, what does it mean to be a senior engineer, to have good technical judgment in the year 2016? Oh, I forgot to click forward on that. Yeah, it's coming, guys. Dudes, people. What is technical judgment? Well, it's choosing where to spend your time, your energy, and your money. And the scarcest resource of all is going to be engineering cycles, right? So you exercise your technical judgment when you're trying to decide if you should use a hosted solution for your continuous delivery or run your own. Or if you should use an AWS API for like RDS or Aurora, or roll your own MySQL cluster, or use a third party like hosted MySQL, or whatever. It's science, it's an art. We're all trying to thread this needle between innovation and stability, between making things frictionless for developers and operationally maintainable. And this is why our job is complicated and interesting and hard. I started thinking a lot about this topic a few months ago when I left Facebook and started a company. The last time I was building infrastructure from scratch, it was about 4 years ago when I was at Parse. And I'm like, I keep up on modern things. I felt pretty up to date on state-of-the-art stuff between now and 4 years ago. And then I started actually doing it. I'm like, God damn it, like, I have so many more decisions that I have to make now, and so many more choices for every single decision, and like, I felt like I was good at this shit. It's actually really stressful and hard. And I want to make as many good decisions from the start as I can, because I don't want my company to fail because I did something really stupid. So, to start with, I did some science, and I have produced this extremely sciencey graph for you. By my calculations, as you can see, the complexity of infrastructure and storage options are going to be absolutely incomprehensible by any human on Earth in 6 months, give or take.
It's 2012 where you started.
No. I started spending more on booze. Yeah. Anyway, you can tell this is true because I have a graph. So let's super quickly talk about how we got here. And the reason for doing that is we can pinpoint some of the specific ways that the landscape is really transforming and changing fast. It's not going to be news to any of you, but it helps us, like, narrow down the set of things that we need to be afraid about and care about, thinking going forward. So like, if you were back working with computers in Y2K, anywhere but Google, your set of choices probably looked something like this. You had the extremely important job of deciding between MySQL or Postgres and PHP or Perl, maybe Python. You were probably running in a data center because you had to, right? How many of you here have ever called a cab on a phone with the wire plugged into the wall to get to the data center to push the power button on your database primary? How many of you here are too young to have ever done that? Yeah, we all hate you. And how did you fix things when they broke? Well, you SSH'd into a server, you tailed some logs, you ran TCP dump and strace and a bunch of command line crap. Like, we were all fucking wizards at debugging individual hosts because individual hosts, that's what you had and that's what mattered, right? So around 10 years ago, we start unpacking these monolith applications into more loosely coupled services connected by REST APIs. And like right now, all of us are like, oh yeah, this is table stakes. This is obviously the way to go. But like, remember at the time, this was confusing and complicated and scary. And there were lots of arguments about, you know, should we do this? Why should we do this? It was a really challenging transition to a new way of thinking about infrastructure and about software. You know, even just a couple years ago, this is like, you know, around the time, you know, Parse was what, 2012. It's like, yeah, you had lots of options, but most of them were not mature enough for an adult engineer to use in production, right? You had a recipe to follow, you know, that was pretty much table stakes. You know, config management, mandatory. Continuous integration, delivery. This all went from being like, you know, experimental to mature. But there were a lot of new trends really percolating on the horizon. Most of us weren't using them because they weren't production ready in open source land. But like, dude, I feel like 2014, 2015 is when like, a lot of these trends kind of tipped over into viability. Platforms as a service, infrastructure as a service, containers, immutable infrastructure, and like an embarrassment of riches when it comes to different storage types, you know? Like, we now have just an embarrassment of riches when it comes to columnar, document, MapReduce, RDBMS, graph, clustering technologies, all of which, let's be clear, are going to fuck you over in their own very special ways, which is why there's also a hosted or managed option for pretty much everything. Because it turns out DBAing is hard, and if you can outsource it to another team, you probably should. So out of all this like chaos and change, what should we be focusing on at a really high level? And how do we prepare for more of this in the future? There are a few major themes, right? We are all now polyglot persistence kids. You know, for a long time it was like you hold the line on one data store. Well, turns out those days are just over. We're gluing together more third-party platforms than ever because in the ops as a service space, you know, nobody should fucking spin up their own Nagios instance now, right? Like, you can use those spare engineering cycles on something that is actually key to your business and, you know, pay one of the, you know, the Datadog, I don't know, what, there are better Nagios as a service. Anyway. I didn't mean the Datadog. I just meant, no, sorry. I meant, there are services out there that are better at Nagios and ganglion. Anyway, what all these things actually have in common is they all dramatically increase complexity. Which is why it's kind of both the best of times and the worst of times to be in technology. There's a lot of creativity and excitement around composable infrastructure. Storage systems that now give us in open source land, basically the ability to do things that Google and Facebook have been doing for years now. And more choices, you might think, oh, more choices are great. And eventually it will be. Eventually there will be some consolidation in the space. The databases that fail to mature will die. Eventually containers will fucking work. But in the meantime, this is actually really hard on the humans who are trying to navigate this space and decide what to build and what to use. It can be cognitively overwhelming because there are not a lot of established best practices that you can fall back on. And there are incredibly few reliable narrators because most people are trying to sell you their own bleeding edge piece of crap. And like, I say that with no judgment. I'm gonna be one of those people in a few months, trying to sell you something that will totally fix all your problems, just give you money. So does this mean that you shouldn't use it? No, not at all. It means that you need to think about your organizational tolerance for risk and where to spend that risk for maximum impact. So I hope by now you're all properly depressed about the world. Who's questioning their life choices to become an engineer? All right.
Try harder than that to chase us away. Bar's closed.
All right, now let's move on to some things that might actually be helpful. Some systematic ways for evaluating technology adoption. And these, like I said, these are the kinds of principles that your senior staff engineers and principal engineers and architects, like the really good ones, have already deeply internalized them and they bring to the table, and you know to value their insight, whether or not they're good at articulating it or if it's just intuitive. I mean, it's great when they can articulate it, but a lot of really great engineers are not great at as good at communicating as they are at just like understanding. So let's interrogate this a little bit and try to unpack what feeds that intuition. Let's start with the prime directive. This applies to every single one of us who works on or with or around technology. So let's see what Captain Picard has to say about it. Your technology exists to serve your mission. What is your mission? Well, I don't know. Maybe your mission is getting people healthcare, or making the world more open and connected, or empowering developers to build mobile apps. Whatever the fuck it is you're doing, building software is not your mission. Thank you. Even if your business is literally writing a database, writing software is still not your mission. That's just a layer of abstraction, right? Your mission is still to do a better job of empowering your customers to achieve their mission. We are not doing tech for the sake of doing tech, unless you're doing it on the weekend, on your own time, fine, whatever. I never want to catch anyone doing technology for the sake of technology anywhere near pipe projection systems. In fact, this leads into my next point, which is that it may be way more helpful to think of software as the enemy. Even though we all presumably like technology to some extent, like, doesn't change the fact that every bit of software, every line of code that you write yourself is something that you or some other unlucky bastard is going to be debugging and maintaining for years. That is your best case scenario. All code is liability. The best code is no code. If you can achieve your mission with writing zero code, good for you. The second best code is code that someone else wrote and maintains, that lots of other people use, but that you can still read if you have to. If you have to go and understand it at 3 a.m., you want that. The worst code is anything else. And it's easy to lose sight of this, right? As a technical leader, anytime you hear sentence fragments like, we should rewrite this thing in React because it's cool, or we should move from Mongo to Postgres because it is just better, or I want to build a new deploy system using Docker because you know, you should figuratively smack them, not literally, but figuratively. It is your responsibility as a leader to make sure that your engineering time is spent on your mission. And as a general rule of thumb, that means write as little software as you have to. Then you have as little to maintain as necessary. Which leads me into the next principle, which is that you should try to reuse solutions and components wherever possible. And side note, this applies like 3 times as hard to storage systems because storage systems have very high maintenance overhead costs, and they are especially punishing when you fail at them. Like every storage component that you add into production, you need to monitor it, graph it, have people on call for it, we have people who couldn't understand it, maintain client compatibilities, write libraries for it, scale it, blah, 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 whatever. Don't underestimate the operational overhead of bringing something new into your system. It is actually, people would often give me shit about us using Mongo at parse, especially back in 2012 when it was insane. Like 1 lock, seriously? You want to host 60,000 mobile apps and have 1 lock? But fact is, Mongo was not optimized for anything. But it had critical qualities that we needed, such as completely flexible schemas, and it ran about as well for all different workloads, right? That, like running a database that you can solve all your problems with, even if it only does it like 70% or 80% as well, is way better than having to run, 5 or 6 different storage types for all of the optimized use cases. Anyway, another way, Dan McKinley, one of my favorite people in the world, how many of you have read his Choose Boring Technology blog post? It's amazing. I have a link to it at the end. You're going to love it. But the way he puts it is optimize globally rather than locally. If you optimize locally for every solution, picking the perfect language, perfect storage system, caching layer, whatever, you end up with this beautiful data center rack. The cost of maintaining any solution over time vastly outweighs the cost of developing it. Now, like I said, this is all contextual, right? If you're a baby startup, you can get away with way more localized chaos. Why? Because who knows if you're going to be around in 6 months, right? You should be optimizing for experimentation and rapid iteration and developer productivity, and that is correct when your time horizon is days or weeks or months. Once you are in a place where your time horizon is many months or years, that's when you need to start shifting your focus back to standardization and operational longevity. And how do we do that? Well, tech leaders, you have one job. Have some process that adds some amount of friction for gating new components into production, like a new language. Somebody decides to start writing new shit in Go one day. Okay, I mean, it doesn't have to be a heavyweight process, right? If you're a 3-person startup, this can be like turning around and going like, hey Rick, hey Christine, I want to do this thing. And they're like, okay, cool, but now we're all aware, so we all share some distributed responsibility for this component, right? If you're a 30,000-person company, this gating process probably involves review committees, like meetings and conversations with stakeholders, a discussion about what it's replacing, all this stuff. What is the relative gain of the new technology? If you're running Ubuntu, for example, and some dude comes in and is like, we should shift to Red Hat. Fuck that guy. Like, there just isn't enough difference to ever justify that, ever, that I can think of. If you are running into scaling limitations with Python and Ruby and you need to discuss moving to something like Go or Rust, like, that is a much larger potential relative gain that you should take seriously. And the last thing I'd say about this is, like, don't micromanage outside the critical path. Like, to some extent, like, you know, turn a little bit of a blind eye when people are like playing around with new things and getting excited, you know. If it's not in the critical path, like, give way fewer fucks. Like, but if it is both core to your mission and in the critical path, you need to have some discipline. Some really good reasons, we kind of just touched on these, good reasons for adding new components. It's critical to a new feature that is core to the mission of your company. Like at Parse, we already had a couple of storage systems, but we added Cassandra because we thought it was important to have an analytics tool. And after looking carefully at MySQL and Mongo and Redis, we realized that that would not work. It justified bringing on yet another storage layer. Sometimes you also need to replace old components that really, really suck. In which case, great, but it's going to be twice as hard, take 3 times as long as your most pessimistic guesses, which is why you need to develop a plan that everyone commits to for not just starting to use a new thing, but like aging out the old thing. I have friends at a company in San Francisco, who I will not name, who started replacing Puppet with Chef 5 or 6 years ago because it was better. They're still running both. They hate themselves, and they should. It's totally legitimate to give preference to something where you and your team already have some expertise, because you will have fewer, to use Rumsfeld's wonderful term, you'll have fewer unknown unknowns, right? All software has gremlins, all software is going to fail in certain ways, and you're a little bit better off if you already know where those gremlins live. Bad reasons, you think it's cool, you went out for drinks with a vendor and they showed you their benchmarks. Or literally anything that Hacker News has to say about anything, good or bad. Which leads me kind of back into Dan McKinley's point again, which is choose boring technology when you can, right? The way he puts it is like, I love this guy so much. He's like, imagine your startup has 3 innovation tokens. If you're using a new database, you've spent one. If you're using React, you spent another. Boring is not bad. The world runs on boring software. If you start a company and you start rewriting cron, You deserve what you're gonna get. For boring basically just means that its failure modes are well understood, right? For databases, this means extensive stress testing in production by people who are doing the same kind of workload as you. Don't forget that part. For language, it means rich library support. Like you're not going to have to rewrite a driver for everything you want to add. Yeah, use boring technology whenever you can. But this is a guidepost, not a rule, because the flip side of this is the earlier stage your startup, the more risks you can and should take, because this is your competitive advantage, right? This is how new startups disrupt the status quo, by being able to move faster and iterate faster and having less sunk costs, right? I love Dan McKinley. I think his advice is great. I quote it all the time, but he wrote that after working at Etsy for many years, which is a fucking lamp stack, right? It's a big website. They do great things, but like they're not like innovating on the core, like the nut of their product, right? So anyway, use boring advice. Great advice when you can take it. Remember that it's contextual. Yeah. Spend that risk and energy only where it gives you a key competitive advantage, because you're going to spend a lot of your time teasing out those unknown unknowns and helping the software grow up alongside you, which is what we did with Mongo. Other people are doing with other, Titan. Sometimes it's worth it. If you do decide to go bleeding edge, some of the questions to ask, okay, so I'm talking a lot to startup people here because that's kind of who I am, but like a lot of this is just as relevant to like Google and Facebook and Microsoft if you replace the someone else's software with should we form a new team to write a new thing? Should we use some off-the-shelf like open source thing, or should we write it ourselves because we can fucking do that? Most of us don't have that option. So is it key to your mission? How confident are you that it's going to be around? This applies at big companies too. Is it just like a couple of people who are really passionate about building this thing? What happens if they leave or they quit? What happens if the thing that they wrote isn't Erlang? And don't forget to ask, how good is the community? Quality communities that are welcoming and not jerky, they make software more likely to succeed and stick around and improve over the long run. I chose Chef in the beginning, not based on any technical reason whatsoever, but because I just spent a couple years using Puppet and they were assholes. Sorry. Okay. Is this being recorded? Fuck. Anyway, I'm just about done here, but so many of these principles boil down to, and I'm an ops nerd, so I have my own, opsy opinions, but so many of these principles boil down to constantly keeping in mind the operational impact and life cycle over time. This is why I feel like it's so important for software engineers to be equally paged. No, more paged. Let's say more paged. This is why I think software engineers should be getting paged more than your so-called, systems, site reliability engineers, whatever. Who is absorbing the operational impact of a new service? You should know this. Is it your developers? Is it your site reliability teams? Is it AWS? Maybe you could totally offload that risk, and if so, do it. which is the corollary, which is make as many ops problems as possible, not your problem. Remember a few years ago, I used to love running postfix and like spam assassin and like, you know, training and ClamAV antivirus programs. Like I was a total mail nerd, right? And then one day, like Google was like, hey, have some mail. And I kicked and fought for a little bit because I was like, I fucking love running my own mail systems. And then I realized, I mean, whether I love it or not is not the question. The question is, I'm an engineer. Is this what I should be spending my engineering cycles on? Is fixing everybody's spam problems? And no. No, it was not. I feel like we're in the middle of a very similar sort of transition where we all used to build our own handcrafted metrics, you know, our own ganglia and graphite and all of these but it's terrible. It sucks your life away. You do it over and over every single place. And that's why there's so much activity in this space, because if it's not core to your business, and monitoring and graphing, for most companies, not core to your business, make it someone else's problem. Because those problems that are core to your business, you have no choice. You have to keep those in-house. You probably can't hire as many engineers as you want to because there just aren't enough to go around. So be very conscious about spending your engineering cycles on those things. And culture can do a lot of heavy lifting for you here. If you can successfully, you know, celebrate and compensate and give bonuses and like make visible the engineers who are removing code, who are deprecating features, who are simplifying and refactoring, then you're creating and reinforcing these reward systems, and you will get more of it. The patterns that you call out and celebrate in your culture are the patterns that absolutely will get repeated. So as a technical leader, it's your job to like surface that work and make it exciting and make it valued, as much as the people who are shipping like shiny products. I can't even, I don't know, product. Anyway, so the good news is your startup is probably not going to succeed or fail based on the language that you choose. I mean, for fuck's sake, Facebook chose PHP. Most companies fail, but they mostly fail for lack of traction or product market fit, not for their choices of technology. Technical problems can usually be fixed if you have the problem of success, which is a great problem to have. However, that doesn't mean that these choices are meaningless, because the choices that you make can have a huge impact on how quickly you can move, how quickly you can change your mind, change direction, how much technical debt you accumulate and how fast, how happy the engineers on your team are, and your ability to recruit, because we are all very gossipy. And that does actually directly contribute to the bottom line success or failure of your company. One last point, engineers, if you are interviewing at a new company, ask questions. Like, remember, you are interviewing them at least as much as they are interviewing you. Ask things like, how many languages do you use? How do you decide whether or not to add another one? How do technical decisions get made? And if you're hiring, the people you're talking to are just like, well, it's a red flag. You should at least dig into that some. Are they hiring you explicitly to help clean up this mess? Are you willing to take on that role? Are they willing to say no? Anyway, there are two sides of this transaction, and like, set yourself up for success as much as you can. So I told you we were going to come up with a manifesto. This is it. Your technology serves your mission. you reuse the solutions that you've developed. You choose as much boring technology that you don't have to maintain wherever you can. You think carefully about your appetite for risk. Have an established process for adding new components. And the longer you survive as a company, like the more mature you get, the more operational impact trumps basically every other decision. So I showed a version of this to a friend of mine, and he's like, yes, doom is on the horizon. It's cool. But like, at what point in the past has that ever been true? Like, a few years ago, we were all bitching about, oh God, I have to learn Java now too? Like, what happened to just having, C or C++? Yeah, fair, right? In a year or two, or a few more years, we're all going to be looking back wistfully at today and being like, remember when we only had to choose between like virtualization versus 5 different kinds of containers and half a dozen schedulers, and there were only 10 different document databases. So enjoy it while you can, because these are already the good old days. Thank you very much. Enjoy the rest of SREcon.